Welcome, everyone. My name is Peter Corliss, Director of Technical Advocacy here at ScyllaDB. I'll be your host for today's webinar, Learning Rust the Hard Way for a Production Kafka plus ScyllaDB Pipeline. Today, you will learn about Numberly and how they made the leap from Python to Rust and what they learned along the way. First, though, a little bit about ScyllaDB. ScyllaDB is a monstrously fast and scalable NoSQL distributed database, perfect for highly available, highly performant terabyte-scale workloads. It was patterned after Apache Cassandra and also offers an Amazon DynamoDB compatible API. Here's a quick snapshot of some of the many companies using ScyllaDB. As you can see, it's not just one industry. Anyone looking to run a big, fast, always-on distributed database can use us. You can start small and keep scaling. There's no barriers to hit as your company or your use cases grow. Without any further ado, I have the pleasure of introducing to you our speaker today, Alexis Jacob, CTO at Numberly. Known as Ultrabug, Alexis is regarded as one of the most, if not the most, active open source contributor to the ScyllaDB ecosystem. Great to see you again, my friend.
Hello, Peter. Thanks for having me. So, as today, I'm going to talk to you about our, not migration, but our experience in transitioning from some Python code base to Rust. And the agenda is as follows. I'm going to explain to you the thought process that made that possible. And then I'm going to share with you some lessons in learning Rust the hard way and why I'm calling this like this. And we'll get into technical details in that. And then we'll take a step back and look at the big picture to see how this experience went and what we can take away from it. So, as Peter said, I'm very involved in a variety of open source projects, and a lot of them are mainly known and written in Python. So I've been doing Python in production for more than 15 years now. Yeah, that's as much a marker that my age is advancing as well as a shock to my colleagues that I could even consider actually to code using another language than Python. So what could trigger such a radical change on me? Numberly is a digital data marketing expert helping brands connect with their customers using all digital channels available. As a data company, we operate on a lot of data that is fast-moving, using an event-driven approach that drives our technological choices towards platforms that allow us to process and react to stimulus as close to real-time as possible. So we combine Kafka and Scylla extensively on streams and specialized pipelines and applications that we'll call data processors here on the schema that you can see. Each of those pipeline data processor applications prepare and enrich the incoming data so that it is useful to the downstream business and partner or client applications. And in our kind of work and line of work, the relevance of data-driven decision is at its best when it's close to the event's time of occurrence, which means that availability and latency are business critical to us. Those data processor apps, Kafka, and of course Scylla can't fail. If they do, we get angry partners and clients, and nobody likes that. Latency and resilience are thus the pillars upon which we build our business reliable platforms. The data industry and ecosystems are always changing. Last fall, we had to adapt 3 of the most demanding data processors written in Python. Those processors applications were doing the job for more than 5 years. They were battle-tested, trustworthy, the Python that you know by heart, right? And as you know, I'm not a low-level programmer, as I always felt C or C++ cumbersome and useless for my needs. But I was following Rust maturation for a while, and I was curious, and I had the feeling that it could find its place in between Python and C++, let's say. So when this opportunity came, I went to my colleagues and I told them something like this. Hey, why not rewrite those 3 Python applications that we know work very well into one Rust application, which we don't even know the language? They look at me, and after the shock, they ask for a rationale rather than just a crazy idea like this. So let me try to explain the thought process. Rust makes promises that more and more people seem to agree with. It's supposed to be secure with memory and thread safety, of course, no runtime garbage collector. It's supposed to be easy to deploy, make no compromises with strong and types, which coming from Python is a bit bizarre. Exhaustivity being mandatory, some built-in error management, and it also plays well and integrates well with Python. So that's pretty interesting on paper. But furthermore, their marketing motto speaks to the marketer inside me, of course. A language empowering everyone to build reliable and efficient software, right? Everyone, yeah, I guess that's me. And reliable and efficient software, that's exactly what I need. Now, careful attendees would ask me, hey, Alexis, you didn't mention speed in that list. Isn't Rust supposed to be super fast? Well, their motto mentioned efficiency, and it's not the same as speed. Efficient software does not always mean faster software. Brett Cannon, a Python core developer, argues that selecting a programming language for being faster on paper is a form of premature optimization. And I agree with him in the sense that the word fast conveys different meanings depending on your objectives. So in my opinion, Rust can be said to be faster as a consequence of being efficient, which does not cover all the items on the list here. Let's demonstrate that on my context. Fast as fast to develop, well, Python is way faster to develop, at least for me. I've been doing this for 15 years, so Rust won't be fast to develop. Is it fast to maintain? Well, very few people at Numberly do know Rust and do it professionally, obviously. So no. Is it fast to prototype using Rust rather than Python? Of course not. The code must be complete to compile and run. Is it fast to process data? Sure, on paper, but to prove it, measure it. And is it fast to cover all failure cases? Yeah, definitely. I mean, there's some error handling primitives right inside the the programming language, so maybe. But in the end, I did not choose Rust to be faster. Our Python code was fast enough to deliver the pipeline processing. So why would I want to lose time? The short answer is innovation. Innovation cannot exist if you don't accept to lose time. The question is to know when and on what project. So the gist of my decision was that I was sure this project was the right one at the right time to foster innovation at Numberly. Now, what will I gain from losing time other than the pain of using semicolons and brackets everywhere? Supposedly, a more reliable software thanks to Rust's unique design and paradigms. This is to say that what makes me slow is also an opportunity to make my software stronger. Let's look at it. Low-level paradigms, ownership, borrowing, lifetimes. At least if it compiles, it's safe. It's nice. Strong type safety, well, it's bizarre coming from Python, but still, it makes your program predictable, maybe more readable as well, maintainable. It can have some nice, it can add some value on this side as well. Compilation for debug and release. The compiler is actually very helpful versus a random Python exception. So that's also a plus in my opinion. Dependency management. Finally, something looking sane compared to the Python mess, to be honest. So I was surprised myself to fall in love with a cargo toml. Exhausting pattern matching, it's a confidence that you're not forgetting something. So it's pretty cool as well. Error management primitives using result. It makes you handle failure right from the language syntax. And that's a big plus for me. Explicit return values as well with using option. It's a clear separation between some value or not, and it's pretty neat. So I can fairly say that I chose Rust because it provided me with the programming paradigms at the right abstraction level that I needed to finally understand and better explain the reliability and performance of my application. And we'll get into that just after. So here I am learning Rust the hard way. Why hard way? Because I had a lot of things to interact with in Rust. So here is an overview of all the aspects, technological stacks that I had to deal with. Of course, learning the syntax itself. Then I had to connect and interact with the Kafka cluster and data. Work on asynchronous latency optimized design, ScyllaDB, obviously, some MongoDB as well, deploy on Kubernetes, run and graph everything using Prometheus and Grafana, and monitor using Sentry as well. Since our time is limited, I will skip through this list to highlight the most insightful parts. So let's start with the first wall I hit right from the start, consuming messages from Kafka. We use Confluent Kafka Community Edition and its schema registry to structurate our Avro encoded messages in our Kafka topics. The bad news is that Confluent Kafka registry adds a magic byte to Kafka message payloads, which breaks vanilla Apache Avro schema deserialization. Luckily for me, Gerhard Klich, I hope I don't break your name, I'm sorry, has worked on a crate to address this problem. And we worked together on improving its performance so that it's production ready. Before we fix this, I used the manual approach shown here to decode Avro messages myself with respect of their schema. Then I hit the second wall, when even if my reading of the Avro payload was possible, I still could not deserialize them. Well, as a total Russian newbie, I blame myself for days before even daring to suspect Apache Avro being the culprit. I eventually read Apache Avro source code and discovered, to my surprise, that this was broken for complex schemas like us. Is anyone in the world using Rust Apache Avro in production? I don't know. So here I am contributing fixes to the Apache Avro Rust implementation, which eventually got merged 3 months later in January this year, thanks to its newly appointed committer, Martin. Thank you again, Martin. Anyway, another unexpected fact that Rust allowed me to prove is that deserializing Avro is faster than deserializing JSON in our case of rich and complex data structures. I say unexpected, but my colleague Ottman was expecting it to be fair, and I was happy to finally prove him right. Once I was finally able to consume messages from Kafka, I started looking at the best pattern to process them. I turned to the Tokio asynchronous runtime, which was very intuitive, coming from Python async.io, to be honest. I played a lot with various code patterns to optimize and make consuming messages from Kafka latency stable and reliable. One of the interesting findings was to not defer the decoding of Avro messages to a green thread, but do it right in the consumer loop. Indeed, since deserialization is a CPU-bound operation, it will benefit from not being cooperative with other green thread tasks. So similar, allowing controlling your parallelism will help stabilize your IO-bound operations. Let's see a real example of that. Once deserialization is done, deferring the rest of my processing, that is IO bound to green threads, helped absorb tail latencies without affecting my Kafka consuming speed. The Grafana dashboard you see here shows that around 9, something made Scylla slower than usual. Scylla select and insert P95 latencies went up by 16, as you can see. At the same time, you can see a bump in my parallelism load as I started having more concurrent green threads processing messages. That's above on the first graph. But it only hit my Kafka consuming latency by a factor of 2 instead of 16 at P95, effectively absorbing tail latencies due to this ephemeral overload in Scylla. This is the typical example of something that was harder to pinpoint and demonstrate in Python, but became clear with Rust. Now to our dear Scylla. I found the Scylla Rust driver to be intuitive and well featured, so I want to once again congratulate the team at Scylla who was working on it. And they are very helpful on their dedicated channel on the Scylla Slack service, so join us there. The new caching session is also very handy to cache your prepare statement so that you don't have to do it yourself like I did at first because it was not existing yet. Beware, there's a little gotcha. Prepared queries are not paged. So if you want them paged to read from, use executiter instead. And I'm showcasing a code example of a production connection to a function to Scylla using SSL, multi-data center awareness, and a caching session. Speaking of multi-data center awareness, I hit a bug in the token-aware load balancing that promptly got fixed by the team and released in 0.4.2. So if you run a multi-DC, make sure that you at least use this version of the crate. Now to Prometheus. Even if it's described late in this presentation, Prometheus is actually the first thing I set up on my application so I could measure the latency and throughput impacts of all the experiments I did. For a test to be meaningful, those measurements must be made right and then graphed right. So here is an example of how I measure Scylla query insertion latency. The first and important gotcha is to set up your histogram bucket correctly with your expected graphing finesse. Here I expect Scylla latency to vary between 50 microseconds and 15 seconds, which is the maximal server timeout I'm allowing for writes. Then I use it like this. I start a timer on the histogram and record its duration on success and drop it on failure so that my metrics are not polluted by possible errors. Once you measure right, you need to visualize and graph right. So I created a detailed and meaningful Grafana dashboard so I could see and compare the results of my Rust application experimentations. Best time invested ever. Make sure you graph as much things as possible. Cache size, query and throughput rates, commits occurrence, know the difference between rates and occurrence, errors by type, etc., etc. There are gotchas into graphing Prometheus histograms, so I'm linking a great article that the folks at Grafana wrote and on how to visualize them right in Grafana. So, was it worth it? Let's take a step back and look at this experience as a whole. The syntax was surprisingly simple and intuitive to adopt, even coming from Python, so I'm confident that it's the right level of abstraction, at least for me. I absolutely failed to resist the temptation of testing and analyzing everything at the lower level. It was an unexpected new joy for me, I must admit. So in the end, most of my time was spent on testing, graphing, analyzing, and trying to come up with a decent and insightful explanation. So this surely does not look like wasted time for me. For the number hungry of you in the audience, here are some numbers taken from the application. So Kafka consumer max throughput with processing, 200K message seconds on 20 partitions. Avro deserialization P50 latency 75 microseconds. It's pretty cool. Scilla Select P50 on almost 2 billion rows table, 250 microseconds. Insert P50 as well on the same kind of tables, 660 microseconds. So it's pretty fast, to be honest. And in the end, I can fairly say that it went better than expected. The Rust crates ecosystem is mature, and it's pretty similar to the Python package index, to be honest. I could replace 3 Python apps totaling 54 pods on Kubernetes by 1 Rust app totaling 20 pods. We helped and worked on making the Scilla Rust driver even better, on the token-aware policy for higher availability, optimize partition key calculations for prepare statements. Good job, Joseph. And we have more to come since we are getting deeper and deeper into it. So even if it was my first Rust application, I felt confident during the development process, which transformed into confidence in a predictable and resilient software. Now, after months of production, the new Rust pipeline processor proves to be very stable and resilient. Sentry is bored, to be honest, and I can say that Rust promises are living up to expectations. Thanks a lot for your attention.
All right, thanks, Alexis. Now it's time to hear from your audience. If you have any questions for Alexis, please again use the Q&A button located at the bottom of your screen to ask questions. Also, if you have any private questions you'd like to ask us at ScyllaDB, please use the Contact Us form on our website at ScyllaDB.com. We've already had a couple of questions asked during the presentation, so let's see what's already queued up. So here's the first one. What was the key thing you learned as a Pythonista moving into Rust work?
That's a good question. I think it's all the lower level point of view that Rust offered me to get a glimpse at, to be honest. So it was a whole new world that maybe I could have had and undertaken as a Pythonista, but I didn't feel confident enough at this time to do it. So yeah.
All right, so here's another question then. What other parts of your infrastructure are you looking to move to Rust?
That's another nice question. There's today mostly pipeline and latency related parts of our pipelines. Let's put it that way. So we have some other applications that are interconnecting Kafka and Redis, for instance, that we plan on migrating as well from Python to Rust. For the same kind of reasons, basically.
Sure, and you just mentioned Redis, and of course, you know, there's a heck of a lot more than just ScyllaDB, Redis, Kafka. What other technologies is Numberly looking at or utilizing in your infrastructure?
We've been playing quite intensively with Janus Graph lately for some data science logic. We are very frustrated that we didn't test Red Panda yet to challenge Kafka on some pipelines. Yeah, I know I've been discussing with Alexander and his folks for a while now, and we are eager to try Red Panda, to be honest. So yeah.
Very good. Well, definitely, you've always shown leadership in technology, and I'm sure that people should, if they haven't been following you on Twitter at Ultrabug, you know, they should definitely follow you there. You have a fascinating blog. You're always producing some incredible information that people should look into. And also, you're also Ultrabug on GitHub. And so is any of your work there on GitHub too for people to look at?
Yeah. I guess there are a lot of stuff
over I know there.
Yeah.
You always have a lot of projects.
And about some new stuff, we also have some special project, but this one will be for Scilla Submit 2023. So stay tuned.
Wonderful.
Mm.
Okay, so that's the time we have with Alexis today. Thank you very much for joining us, Alexis. And before we leave, we have one last audience poll. Okay, just want to take a moment for this quick poll. For sense of scale, we'd like to understand how much data do you have under management in your own transactional database systems? Less than a terabyte, 1 to 50 terabytes, 50 to 100 terabytes, or greater than 100 terabytes. Pick the answer that best matches your current data set. And we'll leave the poll up for a bit for you to answer. In the meantime, I wanted to tell you again about P99Conf. Registration is now open at p99conf.io. It'll be our free virtual event, October 19th and 2022, and so we hope to see you there. All right. Thank you very much for attending today. In due time, you will find this presentation available on the Scylla.com homepage in our webinar section for on-demand viewing. Also remember to register for our workshop next week. If you would like to weigh in on what we present in the future, please contact us either via the form on our website or on Twitter. We'd love to hear your ideas. For now, on behalf of Alexis and myself and all of us at ScyllaDB, enjoy the rest of your day.